Let's look at an example. So I have this triangle with 6 feet, 24 feet, and 20 feet. As a little side note, I don't know, something shows up on the ACT or SAT or college entrance exam or something. For a triangle to even be possible, the two smallest sides have to have a sum, have to add up and be bigger than the third side. That's the only way we know a triangle is possible. So as I'm making these, sometimes I have to ask myself, wait, is this even possible? Are they going to get a goofy answer because this isn't possible? Add two of the sides, the two smallest sides, as long as they're bigger than the other side, then you're good. So I am good. And in this case, this is a side, side, side. Pretty obvious, right? They got all three sides. So I'm going to go to that formula. I'm going to enter in the numbers. But we run into a little sticking point. It's pretty easy to solve, but there's no letters here. Which one's A, which one's B, which one's C? You get to choose. It won't matter. The angles are the angles. How you name them doesn't really matter. I am going to name mine like this. I'll name my angles capital A, capital B, and capital C. That would make this lowercase a, lowercase b, lowercase c. They're always across from their uppercase counterpart. So now we are going to solve for the cosine of A. Cosine of A in our formulas. We will square the two sides on either side of that angle that we're trying to find and add them. So 24 squared plus 6 squared. And then subtract the other side squared, minus 20 squared. That's my numerator. My denominator will be 2 times 24 times 6. So looks something like this. B squared plus 6. You have all those formulas. Remember I said we're squaring either of these and adding them. That's what that is. We're subtracting the other side squared. Check. And then the denominator is 2 times those ones that we added. Not squared anymore, just 6 and 24. Rip that in my calculator. In fact, I do want to put that in my calculator to make sure you're keeping your denominator separate from your numerator. Let's see if I can get this. Give me some light. Hitting buttons. Kind of, sort of. Let's see it. So I want to do 6 squared plus 24 squared minus 20 squared divided by 2 times 6 times 24. All right? That's what it says. What? I did not get what that has. Why not? Well, I didn't keep my numerator and denominator separate. Okay, the calculator would just read this as divide that, do all this, and then divide that by 2. And it's doing order of operations. And if I don't tell it what the denominator is, it's just going to divide by 2 and then times the whole thing by 6 and 24. Not putting the 6 and 24 in the denominator. So I like to do parentheses. 6 squared plus 24 squared minus 20 squared, close parentheses, divided by, open a parenthesis. Keep your denominator and numerator separate. 2 times 6 times 24. And now we're getting, there's the 0.736 that I got. Okay, so just be careful when you plug it in your calculator. I get that. Is that the angle, 0.736? No, it is not, because we haven't taken the inverse cosine. To get A by itself, I have to remove this cosine, and the opposite of taking a cosine is taking an inverse cosine. Make sure you're in degree mode. When we're dealing with triangles and side lengths, we're usually in degrees, not radians very often, so be in degree mode, and we get 42.6 degrees. Nice. Next, we have options, actually. Next, I'm going to stick to the law of cosines, and I'm just going to solve for cosine of B. So let's go back to our picture real quick. If I want the cosine of B this time, we can do this. We can manipulate the law of cosine and say I'm going to square the 2 on either side of it and add them, and then I'm going to subtract the square of the side across from it. So 24 squared plus 20 squared minus 6 squared. That's my numerator, just like before. Then divided by 2 times 24 times 20, the ones that I added. Take the inverse cosine again, and we would get the other angle. B is about, looks like 11.7. Go ahead and do it yourself. Make sure you can jam it in your calculator and get the correct answer. Something I will mention, might as well, I'm here. Once you knew angle A, we have like the ability to do the law of sines. We have A, an angle. We have the side across from it, 20. We could start setting up the law of sines and say 20 over the sine of A equals 24 over the sine of C and solve that route. But, and I haven't explained why yet, I'm going to, I avoid the law of sines like the plague. Okay? I avoid the law of sines like COVID. The law of sines has rules sometimes that give us different answers than we want. So I just flip my formula for the law of cosine and use the law of cosines again, because it will never give me this exception to the rule, which we will talk about. So finally, I have two angles, 42.6, 11.7. We can always find the third angle for any triangle by subtracting from 180, 180 degrees total. Subtract the two I found, and what's left is our third angle. Side, side, side. Lots of formulas in there, but this is trig class. You guys can handle that. No big deal. Just kidding.